Hey guys, it's Mr. Ray here. We're going to end off the course in the next week or so. I'm going to do two final lessons. We're just kind of touching on this last section of the course. I don't want to overwhelm you guys with a lot of new stuff. So I'm going to do a lesson today on multiplying binomials together. We'll learn what that is in a second. And then we'll do a little bit of factoring on the second lesson. So there'll be a lesson. This lesson comes out on Monday. I'll put another lesson out on, let's say, Thursday, and that'll be it. Now I want to give you guys a little bit of time to catch up. So what I'm not going to post a lesson this week. I do want you to finish up all your other lessons. I know a lot of you have fallen behind, and I get the reasons why. It's a tough situation, but I do want to give you some time to catch up. And I will put out a new final assignment, which shouldn't be too tough, shouldn't be very long at all. I'll put that out, say, on Monday, like a week from today. This is the Monday that this is released. So final assignment will go out on the Monday. I'll give you guys a whole week to finish it up to. A little bonus if you finish within the first 3 days or so. And that'll be it for the course. So important thing is get your assignments in. Even if it's late, I'm not taking off any marks. I will be giving bonus marks if you get it in early, as we've discussed. And by the time you have the last assignment, I should have marked, everything else should be marked, and you should have a good indication of where you are in the course, okay? If there's any issues, I will contact you directly about your mark, or if you have concerns of your own, say by Wednesday next week, please send me a remind message and we can have a discussion. Okay? All right, so let's get down to it. So this lesson is called multiplying polynomials. That's a pretty big topic. Really what we're doing today is multiplying a certain polynomial, which is called a binomial. Okay, and the whole lesson is just how to do this. So there's a few terms here. The ones I want to focus on are these three here. So these are all members of polynomials. So all three of these are types of polynomials, and the only difference is how many terms there are. So for example, polynomial could have any number of terms added or subtracted together. Okay, it could have 1, it could have 100. Whereas a monomial, it just has one term, a binomial has 2, and a trinomial has 3. And maybe you remember these prefixes from other words. Mono means 1, bi means 2, and tri means 3, as in the famous Triceratops. Okay, or tripod. So we're going to be focusing on binomials. So examples of binomials would be things like two terms added or subtracted. So here's a really simple one, x plus 1. That's a binomial. I could put brackets around. I could have, x plus y. Now I wouldn't have x plus 2x because those are like terms. They could actually combine them. You notice these things we can't actually put them together and into one term. We can't combine them into a single term. They have to stay like that. I could have something like 2x minus 3. So I have two terms. I have an x and a positive 1. I have an x and a y. I have a 2x and a negative 3. Those are all examples of binomials. So what we're going to learn today is how to multiply two of these together. And how does it work? What do you get? Okay. Now let's just, before we learn some of the other terminology, I just want to dive right into an example. So find the product of two binomials. That just means product means multiply. So we're basically taking two binomials and multiplying. So these are two binomials, 2x plus 3, two terms, x plus 1, two terms, and we're actually going to multiply them together. So now what we're going to do is change it into something simpler to work with, okay? And I'm going to teach you two techniques. So I'll do the same question. The first technique is going to be called FOIL, capital F-O-I-L. And you can see the definition up here before. It's just breaking this down into steps. So this stands for first, outside, inside, last. And you'll see what those mean in a sec. It's just so FOIL is an acronym, first, outside, inside, last. You don't actually have to do it in a special order. It's just a nice word that comes out of those 4 words. So if I was to write the question down here again, 2x plus 3 times x plus 1. Okay, so you think this is like 2 multiplications, right? This thing times this thing, which it is. But it's really 4 multiplications because each of these things inside here, and I have 2 of them, the 2x and the 3, these are both multiplying with the 2 things inside here. So I have 2 things multiplying with 2 things. So I actually have 4 multiplications. And that's where this comes in. There's 4 different words here. So if I start with the 2x, so what I draw are these rainbow arrows. So from the 2x, I draw an arrow to the x. I also draw an arrow from the 2x to the 1. So the 2x has to multiply with the x, the 2x has to multiply with the positive 1, and then the 3 also has to multiply with each of these things. 3 has to multiply with the x, 3 has to multiply with the 1. So there's 4 different multiplications here. Okay, so the word first, outside, inside, last, I don't really care if you use this or not, or you like the rainbow, or you like the method I'll show you in a sec. Whatever works for you is fine. Okay, so now if you look at this first arrow here, sorry, the one that goes from the x to the 2x, that we could say that's first because it's the 2 first terms multiplying together. And then the second longer arrow, that would be like considered your outside, the 2 outside terms multiplying. The 3 with the x, that's like your inside. And then the 3 with the 1, that's your 2 last terms. Okay, so that's where the word comes from. Okay, so now I'm just going to write each of these 4 multiplications together. So the first one was 2x, and I'm going to put everything in brackets. 2x multiplies with the x. That's the first multiplication, the f. And then I'm going to add the next multiplication is also the 2x, but this time it's with the positive 1. I don't have to put the plus 1 here, but if it was a minus 1, I would have to put it. Okay, 2x with the 1. I'm not even going to think about what I have to do yet. I'm just putting the 4 multiplications together. Then I'm going to add the inside, so that's the 3 multiplying with the x. And then finally the 3 multiplying with the 1, that's your outside. Okay, so most people, after they've done this a little bit, they don't have to do this step, but it's a nice safe step. It shows you what you're multiplying. And now we just multiply each one. So a reminder how you multiply 2 of these things together. We first multiply the constants, like the number part. So there's a 2 there. You might not think there's a number there, but it's actually a 1. So 2 with a 1, 2 times 1 is 2. And then we multiply the x's together, x times x. That's not x, that's actually x squared. So x times x is written as x squared. Okay, so 2x squared, that's basically what this was. Then we do the same thing. So the 2 multiplies with the 1, that's 2 again. And this time we just have 1x. So x by itself, we just write it down there. Okay, it's not x squared because there's no other x it's multiplying with, it's just itself. All right, and then we do 3. This time there's only one number part and there's only one variable part, so you can just kind of glue them together, 3x. And then finally 3 times 1 is 3. Okay, and then what you're going to notice, if you do everything in the right order, or the order that FOIL says, you'll notice that the 2 middle terms are usually like terms, which means they both have the same variable to the same exponent. So that means they're like terms, and we can actually combine them. Well, the way we combine them together is we add together the number parts. So if you think about it, if I had a box that had 2 x's and I added 3 more x's, I'd have 5 x's. Okay, so it doesn't change to x squared, this time because we're adding them, okay? When we multiply x's, that's when we get x squared. When we add the x's, it stays as x. We just count how many we have now, okay? And then the 3 was by itself. So this is your final answer. Okay, that's what you get when you multiply these two binomials. You actually get, in this case, you get a trinomial because there's 3 terms now. There's one term, there's a second term, there's a third term. How do you know where to break them apart? You look for the plus or minus signs. So that breaks up the 3 terms. Okay, so we call it a trinomial. We also say because, we go back to the definitions, if we look at the degree is the highest exponent. So if we look for exponents, I mean the highest exponent of these guys was just 1. X and x, that's degree 1, power 1. Here we have a squared, so this is now, we call this a second degree polynomial because it's got a squared in it. And we actually call this a quadratic. So degree 2, that means it's a quadratic. So if you hear the term quadratic, and if we did this entire unit and the next unit, which we're not, you'd learn that anything with a squared term in it is called a quadratic. So you probably, if you're going to take grade 11 math next year, you're going to hear that quite a bit. So here's your first time hearing it. Now, here's a second way of doing the exact same question, and this is called a matrix method. And I know some people love this method and some people don't understand it. You know, whatever works for you. If you're happy with this, that's fine. But this is actually a really good method because it allows you to multiply polynomials that have more than just 2 terms in. You could multiply 2 trinomials together with a matrix. In fact, that might be one of your assignment questions, okay, to get you guys thinking about this. But your homework questions, it'll just be multiplying binomials together. Okay, so what the matrix is like a table, a matrix. So you always make like a 2 by 2 table, 2 rows, 2 columns, just a box with 4 boxes inside, make them nice and square. And what we're going to do is, well, let's put the question again, 2x plus 3 times x plus 1. So I'm going to take I'll just grab the first one here. Okay, 2x is one term and positive 3 is the other. I'm actually going to write them at the top of these 2 columns. I'm going to put a 2x there and a plus 3 there. So I basically broke it into 2 separate terms and then had each term at the top of each column. And then I'm going to take the other one. Again, I got 2 terms because it's a binomial. I'm going to split this into 2 terms, x and positive 1. And I'm going to put these at the beginning of these rows. And then each of these entries, these little boxes, is going to be, I'm going to look at the column, I'm going to look at the row, and I'm going to multiply these 2 together. So for example, what I'm going to put inside here is going to be, and it doesn't matter what order you look at it, x times 2x. So x times 2x is going to be 2x squared. And then this entry over here will be x times 3, or 3 times x. That's just, I'll put the sign in front, plus 3x. And then over here, I've got, 1 times 2x. And 1 times anything is just the thing you're multiplying. So plus 2x. And then 1 times 3 is plus 3. Okay? So if you notice, these 4 things here are exactly the same as these 4 things here because we got these the same way we got these. It's just a different way of looking at it. A lot less writing here. So for those of you that would rather just think the question instead of writing out all sorts of stuff, this might be the better way. Now, if I draw like a diagonal going up, here are those 2 terms that are like terms, 2x and 3x. So when I put my final answer, I'm just going to list out everything in these boxes, but when I get to the x, I'm going to combine these 2. So I always start with the highest degree term, 2x squared, I'm going to combine these two together. 2x plus 3x is plus 5x, and then plus 3 from the bottom. You notice these are exactly the same answers. Okay, so whatever method you like, I'll do one of each for the next two questions. Now, if you actually, the thing I like about matrix, if I had something with three terms, say it was like 2x plus 3 plus x squared, I just put another column out here and put the third term there, and then just do my multiplication here with these two guys here, and that works too. So matrix is more expandable to other multiplications, where FOIL is strictly just for binomial times binomial, because that's what the FOIL acronym actually means. Okay, so there's your first binomial times binomial. All right, so we're going to practice two more and then do a little mini word problem. So this one I'm going to do, so I'll do matrix for this one, and I'll do FOIL for this one. Just to give you one more example of each. Okay, so I'm multiplying these two, so I'm going to make my 4 by 4, sorry, 2 by 2 array, and it doesn't matter, I didn't mention this, it doesn't matter which one you put on the top or on the side. Maybe I'll do it the opposite way this time. I'll put the x minus 4 over here, so that's going to be x there and minus 4 here, and then the 2x plus 1 can go here. Okay, and now we're going to multiply. This is going to be x times 2x, so that's going to be 2 times x is x squared. This is x times 1, so that's just 1x. This is going to be negative 4 times 2x. So negative 4 times 2 is negative 8. And then we just have the 1x. And negative 4 times positive 1 is negative 4. And here's my diagonal, where I've got like terms usually. And I'll just put the final answer. So start in the top left corner and work your way down. That's the highest degree to the lowest degree. 2x squared. And then I've got negative 8x plus 1x. So that's negative 7x minus 4. Okay, so that was pretty quick. Let's try this one using FOIL. Now, this is a little different. It doesn't look like there's two binomials here. It looks like there's one, but there's a squared sign. So what does that mean? Well, remember squared means you basically multiply whatever's here by itself 2 times. So in this case, I'm multiplying 3x plus 2 times itself, 3x plus 2. So now all of a sudden you can see, oh, that's actually a binomial times a binomial. It just looks, it's the same binomial that we're multiplying, both cases. Okay, so let's move this down a little bit. So I'm going to use FOIL this time. So I'm going to draw my arrows. There's my first, there's my outside, inside, and last. And now I just start listing these guys out. So 3x times 3x. You can write these out if you want, or if you can just multiply them right now, that's fine too. Then I have 3x times, always put a plus sign between the 4 multiplications. So 3x times 2 plus 2 times 3x plus 2 times 2. Okay. So 3x times 3x. So we do the number part first. 3 times 3 is 9. X times x. So now it's multiplying x's. So you add, you make an exponent. How many times do we multiply x by itself? 2 times. All right? 3x times 2. So this becomes 3 times 2 is 6. Then you had just the 1x there, so it's x. And 2 times 3, 6 again, with another x. And then the 4 here. And again, now we've got that the two like terms in the middle, so we just add them together. Another word for that, simplifying. That'd be simplifying like terms. So 6x plus 6x, remember, we're just adding these numbers together. So 6 plus 6 is 12. And when we're adding x's, we already know they're like terms. We don't change the power, we just leave it as an x. Okay. Okay, and then plus 4 from before, and that's it. Okay, now a little application question here. There'll be one of these on the assignment. It's not too many applications in this unit, so that's a good thing. We have a rectangular ski area. It has width is equal to x plus 1 and the length is equal to x plus 3. Both measures are in kilometers. Find the quadratic expression that represents the ski area. So before I even do this, I want to draw a little picture of what's going on. So there's my rectangular ski area. The width is equal to x plus 1. Now I don't care which side you draw the width. X plus 3. So I saw they were pretty close together. I want to put the plus 3 as the longer side because since I drew this that way, that should be the x plus 3. Okay. So we want an expression for the ski area. So the area is inside here, right? And the area of a rectangle is length times width. Okay, and what's the length? Well, the length is, well, it says here, let's just use the order they gave it, x plus 3, x plus 1. It doesn't really matter what order you do this. And this is, now you can see this is what we just learned. How do we multiply x plus 3 and x plus 1? Well, let's do the FOIL. So we've got x times x. Here's our 4 rainbow arrows. So x times x. This time I'm just going to multiply without doing that step in the middle. X times x, that's x squared. X times 1, that's just 1x. 3 times x, that's 3x. 3 times 1 is 3. And just like every other time, we've got the two like terms in the middle. X squared, we can add these together, so we get 1 plus 3 is 4. And just x. So there's what they're looking for. When they ask for an expression, it's basically going to be like an equation. Like, what is the area equal to? It's going to be equal to x squared plus 4x plus 3. And then it says, using what we just did, what would the actual area be if x was 2? So I'll just repeat what we did down here. There's our formula for the area. So what they're saying is we're going to change x to 2. So that's equal to, everywhere I see an x, I'm not going to actually do the calculation yet, 2 squared plus 4 times x would be 4 times 2 plus 3. Okay, and now we do the math. So each of these we evaluate. 2 squared is 4 plus 4 times 2 is 8 plus 3. And we add these together, we get 12 plus 3 is 15. Now, they told us these were measured in kilometers, right? So one of the things before you finish the question off is you say, are there any units for this? Well, the units, this is like x plus 3 kilometers, and this is x plus 1 kilometer. So the area would be kilometers squared. Now, another way I could have done this is go back to the picture and just said, okay, well, what's going to happen if x was 2? Well, then this side would be 5, this side would be 3, 2 plus 1, 2 plus 3, and then the area would just be 5 times 3, which is also 15. Okay, so a couple different ways of looking at it, but the answer would be the area of the ski area would be 15 kilometers squared. Okay, got a few homework questions for you to try out. Just make sure you know how to do it. I'm going to have the office hours again, usual times, Tuesday and Thursday. So if you need help, please come and talk to me. It's been kind of lonely on there the last few weeks. So if you do have a question, you probably be the only one there. So get lots of help. Okay. All right, guys, have a great week.